Okay, for this part of the free response review, we're going to look at all the questions that are not that require open response, but are not so simple equations, and are not the performance test, which is that last big problem. So the first one is work with parabolas. And if you had to pick one thing to be really, really good at for this test, is this. Because that's going to come up the most out of all the equations. First thing it says is find the intercepts of the parabola. The y-intercept's real easy. All I got to do is plug in 0 for x. I got y equals -5. So there's my y-intercept. Okay, the x-intercepts, okay, now I'm going to let y equals 0. And this does not factor, so I'm going to have to use the quadratic formula. So, -b plus or minus square root of b squared minus 4ac all over 2a. Okay, so now I'm going to take this and just plug in my numbers. So b is -6, so I'll get -6 is 6. When I do my b squared part, you should always square in your head. -6 squared is 36. Then it's minus 4 times 3 times -5 over 2 times 3. So simplifying in here, I have -4 times 3, that's -12 times -5 is +60, plus 36 is 96. Now I'm going to simplify this square root. So I often will try to look for perfect squares that go into it. This one might not be obvious, so another method you can use is just to kind of factor it, like using a factor tree. So if I took 96, 96 is 2 times 48. 48 is 6 times 8. 8 is 4 times 2. And then 4 is 2 times 2. So what I've got is I've got 1, 2, 3, 4 2's, and 6 is 2 times 3. So I got 1, 2, 3, 4, 5 2's and a 3. 1, 2, 3, 4, 5, and then 3. Every time I get a pair, I can take something out. So I can take out a 2, take out another 2. So what I have right here, 2's will come out, both sets of 2's will come out, and then I've got 6 left over. So this is going to be the square root of, I'm going to do square root of 96, 4 times 4 times 6. Square root of 4 is 2, square root of 4 is 2, so 2 times 2 would give me 4. And I got down to this. Okay. Now, I want to reduce this. If you look at all 3 of these terms, don't be tempted to cross out the 6's. 2 goes into all of those, so I'm going to divide each of these by 2. This becomes 3, that becomes 2, that one becomes 3. Then you could punch this in your calculator. You could have used the original before we simplified it to punch in to get the decimal answers. So this, first of all, the answers and using the correct notation for the intercepts, punching the calculator. I do 3 plus 2 root 6, hit enter, divided by 3. I get 2.633. When I do 3 minus 2 root 6, hit enter, divided by 3, I get -0.633. And of course we had our y-intercept, so I don't want to make sure I forget that. Okay, now we're going to put the equation in vertex form, and we're going to state the vertex. So, and also showed maybe a possible shortcut for doing this guy. If you did this part B first, you might find it actually easier. So if you're good at completing the square, then what you can do is, if I'm going to complete the square on this one to get it in vertex form, I'm going to start by adding 5. Then I'll factor out a 3. I'm leaving a little bit of a space here. Now if you use completing the square, the key thing is you have to have it as this plain old x squared. You're going to have to factor out whatever's in front. Then I take half of the term that's here and square it. So I get -1 squared is +1. But what I really added to this side wasn't 1, I added 3. So I got to add 3 to that side. I get y plus 8 equals 3 times x minus 1 squared. then I can subtract the 8. Now, the advantage of this one right here, let's say you're terrible with quadratic formula. I could solve my equation now by letting y equal 0, and I'd have 8 equals 3 times x minus 1 squared. You'd have 8/3 equals x minus 1 squared. Then you can do square root, do plus or minus. It gets to be a little more complicated when you have to go simplify it, though. So that's why the quadratic formula might still be easier. But if you don't know how to use the quadratic formula, you can at least possibly figure out the answer by solving this equation with y equals 0. My vertex, opposite of what's in the parentheses. So it's 1, -8. Now, if you can't do this kind of a steps, there's another option. Take the equation we have here and let it equal the y-intercept. Then I'll add 5 to both sides. So I got 0 equals 3x squared minus 6x. I can factor out 3x. I look for where the answers are here, which would be at x equals 0 and x equals 2. Halfway in between those is where my vertex occurs. My vertex is going to occur at 1, comma, something. To find out what that something is, I'm going to take 1 and plug it all the way back into my original equation up here. So if I plug in 1, I get 3 minus 6 minus 5. That equals -8. Then finally, if I did it this method, I still got to state what the vertex form is. So my vertex is at 1, -8. So it's x minus 1 squared minus 8. And the number that's out in front is exactly the same number that the A1 was here. Okay, the last thing I wanted you to do is to use this information to graph it. So here's our graph. I've got my vertex at 1, -8, so I plot that point. We had our y-intercept of 0, -5. Lost my mouse. There it is. Okay. We had y-intercept at 0, -5, so I'll plot that point. Then, because of symmetry, I know there's another point right here. Now, if you didn't get that point, it wouldn't matter as much. Then I've got my intercepts at -0.633 and 2.633. And now I'm just going to sketch my parabola. Okay, so that was question number 5. Question number 6 deals with systems of inequalities. Okay, so we're going to sketch the region bounded by the curves below. So we're going to take them one at a time. We have y is greater than x minus 3 squared minus 4. So I think about my vertex. My vertex is at 3, -4. I plot that point. It is a positive parabola. So I'm going to be having it open upward. And since I don't have equals, I'm going to make it with a dashed line. Now, it's a greater than. So for this, when I work with a greater than, what I'm going to do is basically I'd be shading what is above it. So right now, that's my solution set just after the first one. Next one is a circle. My center is at -1, 2. Radius is 4. So I'll go out 4. I'll go 1, 2, 3, 4. Up 4. Backwards 4. Down 4. And then I can draw my circle. Now, for circles, greater than means the radius is bigger than 4. Well, that'd be going past 4. It's everything outside of it. Less than would be all the inside stuff. That means the radius is less than 4. You'd have everything that's on the inside. So now my solution is still what's inside the parabola, but I do not include this section right there. Okay, the last one is the absolute value. So I've got my vertex is at 4, 6. It's flipped over, so I'm going to make a V shape. Then, right in here, I'm going to do the shading below it. The shaded area is right there. Okay, we had a little bit of a break right there. So the last one we're going to be looking at is using box plots and talking about things like center and spread. So we have a large school, has a varsity and junior varsity track team. We're going to assume it's like the boys varsity team, okay, and JV teams. They have a number of students that compete in the 400-meter run. 5-point summary for the varsity team is 50, 52, 55, 58, 65. So what this 5-point summary means, 50 is the minimum, 55 is the median, 65 is the max. 52 is the first quartile, that's like the 25% point. 58 is the third quartile, that's like the 75% point. Then for the JV runners, we have all of these times. All the times listed are in seconds. We're going to find the 5-point summary for the JV team. Now to do that 5-point summary, I'm going to first of all need to put the data in order. So what I typically do is I'll go through and I'll try to find what is the lowest time. That would be a 55. So I'm going to write it up here because I already know I have it. And then I would cross it off. Then I go through, it says, okay, I've got 56. Cross it off. Then I add a 57. Cross it off, and so on. Until I got my whole list. Okay, so now I got my list. I'm going to go over and I'm going to find the median. Well, if I count up how many I have, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 values here. If you want to find the median, take that number, add 1. So 13 plus 1 gives me 14. Divided by 2 is the 7th value. So my 7th value is 1, 2, 3, 4, 5, 6, 7. Okay. I have half the values are below 60. 1, 2, 3, 4, 5, 6. Half the values are above 60. 1, 2, 3, 4, 5, 6. Even though I got that same 60 here, it doesn't matter. I still kind of apply those rules. So 60 would still be classified as the median. Now when I start to write my summary, my lowest point was 55. My highest number was 68. 60 is my median. Now I got to find my quartiles. Well, your quartiles are like finding the median of the lower half and median of the upper half. So the median of the lower half, well, these are these numbers. I've already got the 60 taken care of right here. Well, I've got 6 numbers left. So I'm going to go halfway between. So if I did 6 plus 1, it'd be 7 divided by 2 would be 3.5. So it happens between the third and the fourth value. Same thing happens up here. It's between the third and the fourth value. That's typically what you're going to run into when you do this kind of thing. They're going to behave the same for the quartiles. Okay, so my first quartile is 57.5. Third quartile is 62.5. Now I've got my 5-point summary. So we know we could put commas between each one of these now. And there's my 5-point summary. Okay, now we're going to create box plots for both the varsity and JV teams. For the varsity, I'm going to do my interquartile range. My box part is the numbers that go from the first quartile to the third quartile. So 52 to 58 is where my box is. So I go 52 to 58. Let's kind of look at my chart below. Then I have a minimum value of 50, so my whisker, they call this, goes out to 50. And then my highest value goes out to 65. And that's where that one stops. Then I also want to include my median. My median in this case was 55. And I just draw that as a vertical line. Now I can see everything. I've got a visual representation of that 5-point summary. JV team, do the same thing. My box goes from 57.5 to 62.5. Minimum value was 55. Maximum value was 68. And my median was at 60. Then I ask you to compare the center and spread. for the JV and varsity teams. And I already had the answer kind of written down here. So I forgot to animate that part. So if you look at it, the center, you're going to look at the idea of the median. So the varsity, their median was 60. Or their median was 55. For the JV, their median was 60. So the center for the varsity is lower than the JV. Now you got to remember, these are times I can race, so that's actually better. It's better to run the 455 seconds versus 60 seconds. Then for the idea of spread, you're going to look at primarily on this one the interquartile range, the size of the box. Now the interquartile range on these are really close, so the spreads are very similar. So what we're going to see, the varsity, their interquartile range went from 52 to 58. So it is 58 minus 52 is 6. So that's how I got an IQR of 6. For the JV, 62.5 minus 57.5, that is an interquartile range of 5. So the spread for the varsity is slightly larger. So you can say they're pretty similar. There really wasn't that much difference. Now, the thing I don't have on here also is we have Ryan is on the JV team and has the best time. So you got to realize the best time is that score of 55. It's not the 68. He thinks he should be placed on the varsity team. So we want to know, how does Ryan's time compare to the varsity team? And should he move up to varsity? We got to explain. Well, if I look at that score of 55, that's the same as the median. So his time is as good as at least half of the varsity. So that tells you that, yeah, he's a really good runner. But the question is, should he go up to the varsity team? Well, this depends. He says, yes, he's quite capable. He's equivalent to the other varsity players. He's right in the middle. Or he could choose to be the best JV player. So there's really not a right or wrong answer. It's just kind of how you would justify it. He says, no, he shouldn't move up because he'll be winning all the races in JV. Versus, yeah, he should go to varsity because, he's just as good as the varsity players. Hey, both answers are correct. It depends on which way you look at it.